All right, so we're going to talk about systems of equations. And so there are three different ways that you can solve systems of equations. They are by substitution, by graphing, and by elimination. So we're going to talk about each of those and do a few examples for each. And you need to be sure that you can do each of them, but then eventually you'll be able to choose which one you prefer to use. All right, and we'll talk a little bit more about that as we go. So the first one we're going to talk about in a system of equations is just when we have more than one equation. So if we have two equations, we're going to have two variables, an x and a y in both of those. So we're going to solve for x and y. And what we are really finding is where is the ordered pair where those two lines cross. And that's what we're looking for, a solution, which is where they cross. All right. So we're going to solve for x and y. So on substitution, this is a 4 if you can't read it. We have one that's already solved for a variable, and you need that for substitution, because what I'm going to do then is I'm going to take this and I'm going to substitute it in for x in the other equation. Since I have an x equals, if it were a y equals, I'd put it in for the y in the other equation. All right, so let's do that. So we're going to put this in place of x in the other equation. So you write the equation, in place of x, we'll put a y plus 4, and then finish writing the equation. Now notice in that we only have a y variable. So that's how we're able to solve for y. So now it's just using your algebra. We're going to distribute the 3 through. All right, so we have 3y and 2y. Combined like terms are 5y. Okay, so it's just basic solving. We want to eliminate this, so we're going to subtract 12. Divide by your coefficient, and y is equal to 3. All right, so we know our y value, and now we need to find our x value. So I can bring this, and I can put it into either equation, this one or this one. It does not matter. You just want to maybe choose what would be easier. So if I put a 3 in for y right here, so we would have, right, oops, let me write that correctly. I just put a 3 in for y right here. So we have 3 plus 4, so x equals 7. So write your solution as an ordered pair, x value, y value. And what that means is that is the point where those two lines cross. All right. So let's do another one. How about this one? So this one's a little bit, when we write this one out, so notice the difference on this problem than this one. It doesn't have one variable that it's solved for. There's not an x equal and there's not a y equal. So your first step then is going to have to solve either one of these for an x or a y. Now, just as a hint, I probably want to use this one and either solve for a y or an x. It doesn't matter. If I choose one of these, notice, like for example, if I wanted to solve this for y, I would have to subtract 3x, right? Then divide by -2, so I'm going to have fractions there. Whereas these that just have a coefficient of 1, I don't have to divide, so I just have a pretty simple, I'm not going to have any fractions that I have to deal with for that. So that's why this one that was already solved for x, that's kind of why we want to do that. So I'm just making that a little bit bigger there. All right, so let's go ahead and solve. It doesn't matter if I want to solve for x or y. I'm just going to solve for y. I could solve for x either way. I'm going to write that variable first. All right, so what that means then is I'm going to take this. Now don't put it back into the same equation you got or it won't work. It's just going to come out as 0. I'm going to put it back into the other equation for y, since I solved for y. So let's do that. So we have 3x, and this time we're putting it in for y, so -2. So in place of y, we're going to put in a -x plus 8. So really we're just substituting one equation into the other. That's why it's called substitution. Now let's distribute this -2 through. So we have 3x, negative 2 times a negative x is a positive 2x. Negative 2 times 8 is a negative 16 equals 19. Combine your like terms. So here we have 5x. Okay, again, we're solving for the variable. So let's eliminate that negative 16. And then divide by your coefficient. So here we have x is equal to 7. Okay. Now I got to come back over here. Now I can use this equation. I could even use this one, but I would just suggest using this one or this one to put a 7 in for x. Either one will give you the same answer, so you could choose either of the equations. So I'm going to come back here. In place of the x, we'll put a 7 right here. So y equals negative 7 plus 8, so y is equal to 1. Oops, sorry, I went off the screen there. So my ordered pair for the solution is going to be 7, 1, where those two lines cross. Try and get that to zoom in a little bit better. All right, so let's do one more. So let's take this one. Now on your study guide, this is the first one for graphing, and I'm going to come to that in just a minute, but I want to use the same problem to use for substitution. All right, so let's see here. Let me write this out. So before I solve this by graphing, which is what's on your study guide, I'm going to take that same problem and I'm going to solve it using substitution. All right. So when I look at these and I think about what am I going to solve for? Well, these both have a coefficient greater than 1. So does this one. Even though this is negative, it's still a 1 there. So that's the one I would choose. Now I could do any of them. It doesn't matter. It's just sometimes you might have fractions and they're not as fun to work with, right? So I'm going to take this problem and I'm going to solve it for y. And so let's subtract 2x. Always write your variable first. That's a good habit to get into. And then we want to get rid of this negative. So I'm going to either divide or multiply through by negative 1. So that gives us y equals 2x minus 6. All right, so now we have, I'm going to rewrite down here, we have this equation, y equals 2x minus 6, which is exactly the same as that equation. I've just rearranged it. And then I'm just going to rewrite this equation again. So these are the two that I'm working with. So that's going to be a lot easier to use for substitution. Kind of running out of room here, let me. All right. So what I'm going to do is I'm going to substitute this one into this one because this one now is a y equals. So I'm going to put it in for y right here. So let's do that. So we have 4x minus 2, and then in place of the y, we're going to put in this 2x minus 6. And then let's distribute. So this becomes a negative 4x plus 12. And we'll combine like terms. Well, what happens here? 4x minus 4x, that just becomes 0. So these cancel each other out, and we're left with 12 is equal to 8. Well, that is not true, right? That is not true. They are not equal. So that means is that this is a no solution. All right, there's not a solution for it. So now what I'm going to do is I'm going to come back to this one in just a few minutes, all right? When we talk about graphing, we'll come back to that in just a second. So my answer to that would be no solution because 12 does not equal 8. All right, so let's do a couple different ones. I want to do graphing before we get to that one. We'll come back to that one in just a second. So these are not on your study guide. These are just a couple I've thrown in. So let's start with this one. So now you learned how to solve a system, find an x and a y by substitution. Okay, now we're going to use graphing. So let's begin with this one. Y equals, like I said, if you have your study guides, these are not on there. All right. So for graphing, all we're going to do is graph both of those lines. So remember when we do this, we have to be sure that we've solved each equation for y. Then we can graph them. Well, for this problem, they were already solved for y, which was nice. So You do want to be as accurate as you can. So when you're doing these, if you can use graph paper, that's great. I mean, if you can't, that's totally fine too. Sometimes it's just not exact. It's not as easy to find, and you'll probably see through my example because I'm not using a ruler or my graph paper. So, okay, let's start with the top one. So we're going to graph this. I'll just add a few more here. All right, so we're going to go, this is our y-intercept, right? So we're going to go up to 3, and we're going to put a point there. If this is a whole number, let's go ahead and put it over 1. So from there, we're going to go up 4 and 1 to the right. Okay. And you can do it backwards if you want to, just so you can kind of line your down 4, 1 to the left. But now let's graph that line best we can here. The pressure, it's not too straight, but all right, there we go. So now let's graph this one. So when we graph this line, we're going to start, our y-intercept is -2, and then we're going to have a -1 over 1. So from here, remember, if it's negative, we're going to go down 1 and 1 to the right. I'll just turn my volume down there. There we go. All right. So that'll get off there in just a second. There we go. All right. So so here's my line now. I'm going to turn my paper and draw this line. So remember, I went down 1, 1 to the right. Just did it a couple of times there. So I'm going to just turn that so I can draw a straight line the best I can. Okay, bear with me here. I'm just trying to make this fairly straight. All right, so it's not great, but there is my second line I just drew. So what I want to find is and mine's off a little bit, you guys, but I want to find where the point is that those cross. So where this point is supposed to be, where those cross, is at -1, -1. And that's the problem when you use, when you're just sketching it, because your ticks aren't equal, right? So that's why it doesn't look exactly like -1, -1. So that's why graph paper would be really nice to use for this. If you have it on a test, you'll have a graph to do it on. So, all right, so let's look at another one. So how about this one? Okay, so here's another one to graph. So now notice neither one of these are solved for y. But if I'm going to graph them, then I need to have it solved for y. So on this first one, I'm going to subtract 4x from both sides. I guess I can show that here. So we'll subtract 4x because we always want to solve for y when we're graphing. Write your x value first. Okay, so there's our first one. Now let's just go ahead and do the second one. Again, we want to get y by itself, so let's eliminate the x. And remember, we can't have a negative leading coefficient here on the y. So we're going to just divide by -1 or multiply through. Either you get the same answer. Y is equal to, this becomes a positive x minus 3. Positive divided by negative. All right, so here are my two equations now. So let's go ahead and graph those. Again, there's a good chance mine's going to have some error in it. All right, so let's start with this one. So we're going to start at a +2, and then we're going to put this over 1, right? So we have our rise and our run. And so we're going to go down 4 and 1 to the right. 1, 2, 3, 4, 1 to the right. You want to do it a couple times? And then draw that line. Okay. All right, now let's do this line over here. It's blurry to me, but all right. So here, it's almost when you're at the eye doctor and they're saying A or B. and you can't tell the difference? That's kind of how I am right now, so sorry. All right, so here we're going to go down -3, start there, and then this is 1. We'll put it over 1. So up 1 and over 1, and then we'll draw that line. Okay. So where that comes where this line crosses, again, mine's not exact, but it should be at 1, -2. So this solution is 1, -2. So you can see that graphing, I mean, it's great if you have it on graph paper and it's exact, but when you are dealing with fractions, let's say, for example, that maybe my y-intercept here is 9/2 or 3/2. Well, when I go to put that y-intercept on here, I have to estimate about where that would be. Like, where is 3/2? Well, it's about 1.5, but I have to estimate. So when I estimate, that's not going to give me exact answers. So that's why graphing is really not used very often for that. But what's nice is when in the real world, when you are graphing rates or you're graphing different, depending, what you're talking about, you can maybe find a break-even point when you're trying to find profit, and so there's really good reasoning for using it, but it would just be needed to be done probably a little more accurately on a calculator or something where you could find that exact point, okay? But anyway, so usually you're not going to use graphing as often. All right, now I want you to think about when I talked about this problem right here that turned out to be a no solution. If I graph 2 lines and it's a no solution, what do you think those 2 lines are going to look like? If I graph them and they cross, that's the point, that's the solution. So if there's no solution, that means those 2 lines are not going to cross, meaning that they would be parallel. And so that is what this last problem is right here on the study guide that you have. I just used the same problem to solve to show you how to do it algebraically. But let's go ahead and take a look at it. All right, so here's the problem and solved by graphing. It's the same one we did on our substitution. So we're going to solve this for y. So let's do that first. And again, we have to solve for y when we graph, so we can use the slope-intercept form when we graph it. Put it in slope-intercept form to graph it. All right, divide by -1. So y is equal to, this becomes a positive 2x minus 6. Okay. All right, so let's do the other one. Got to solve them both for y. So we'll eliminate the 4x by subtracting. I'm running out of room there. Divide now by this coefficient, so divide everything by -2. So y is equal to negative divided by negative, positive 2x minus 4. All right, now notice that their slopes are the same. So if I have 2 lines that have the same slope, they're never going to cross. So those are just things that you can think about, even though we're going to go ahead and graph it. Kind of think about that. I really wouldn't even have to graph it if I knew when I looked at it that my slopes were the same. All right, so -6. 1, 2, 3, 4, 5, 6. There we go. And we're going to go up 2, 1 to the right. And we'll graph that the best we can here. Okay. Oh, going off the paper. There we go. All right, over here now, we're going to go down 4. And then we're going to put that over 1. So here's our rise, here's our run. So we're going to go up 2 and 1 to the right. 2, 1 to the right. So this is kind of hard to tell here on mine, but those lines are going to stay parallel where they will not cross. So that then is a no solution. And you can write out no solution, or you can use this empty set symbol with as a circle with a line through it, either one. All right, so that crew is substitution and graphing. So let's move on to another one that's called elimination. All right, so elimination is just being able to eliminate one of the variables. So for example, I'm not going to start with the same one that is on your study guide. I'm going to start with the number 5 if you have that here. Let me write this up here first. All right, so this one's elimination. This is the third way to solve systems of equations. So when you use elimination, that just means you have your x and your y on the same side. And what you want to do is, I want to find a number that either the x or the y's, I want to make them the same number, but opposite signs, so that when I add down, they become 0 and they're eliminated. So what's nice about this one is I already have a positive and a negative. So I wouldn't have to change that like I would here. So for example, here I have a 4 and a 3, so I could make the number 12. So I would multiply this whole equation through by 3, this whole equation through by 4, and then after I do that, I'm going to have a positive 12 and a negative 12. So when I add down, the y's are eliminated, they're gone, and I only have the x's left to solve for. Now if I chose these, which you can, then maybe you would choose the number 6, right? They both, or I mean I could choose 18 also, it doesn't matter. But I would try and, it's easier to work with the smaller numbers. So if I wanted to make both of these 6, that's fine. But remember, one has to be positive and one has to be negative so that they add to 0. So I may multiply this through by 2, everything through by 2. That gives me a 6 here. But then I'd have to multiply this through by negative 3, because then I'd need to have a negative 6 here in order for these to add to 0. So not only do I have to make these numbers the same, but I also have to change the sign on one of them. So that's just one more step I don't have to do if the signs are already opposite. So what I'm going to do is I'm going to go ahead and just make these 12, okay, because I know 4 and 3 can become 12. So I'm going to multiply this through by 3, and then I'd have to multiply this through by 4. So let's do that. And remember, when you multiply 3, you have to multiply every single term in your equation to keep that balanced. So let's distribute that 3 through. So 3 times 3x, 3 times 4y, and 3 times 16. And then here we have 4 times 2x, 4 times a negative 3, and 4 times 22. All right, so do you see what we did? So now when I add these, they're gone. That's why it's called elimination. Those will be eliminated. So let's add down here. This becomes 0, and 48 and 88, 136. Now let's solve by, divide by 17 so we can solve for x. And 17 goes in 8 times. The 136 divided by 17 is 8. All right, so I have found the x value. Now I still have to find the y value. So I can go back and use the original equations, which I would suggest in these, or I could use these. These are equivalent equations. They're still the same equations. I just have to divide the 3 back out, divide the 4 back out. So because these numbers are smaller, I'm just going to take the original one and I'm going to put, I can take either one of these. I'm just going to choose this one just because I decided to do that. So I'm going to take that equation and I'm just going to put an 8 in for x so I can find the y value. Okay, so that's just evaluating when x is 8, what is y? Okay, so we multiply, we're trying to solve for y. So here we have negative 3y is equal to 6, 22 minus 16. So here we find y is equal to a negative 2. So we have this ordered pair, 8, negative 2. If I were to graph these two lines, that is where those lines are going to cross. I could use substitution on this. I would just have to solve one of these for x or y, which isn't very nice, right? Because they're going to be fractions. So that's why I don't want to have to do that. All right, so here's another elimination that was set up like this. So So if I were looking at this problem, I would use substitution. And do you see why? Because I already have this solved for y, so I just put y in for this equation, right? And then go ahead and solve for x. But because this says use elimination, it's not giving me a choice, then that means I'm going to solve it using elimination. So that means I have to have the x and the y on the same side. So I'm going to take this equation right here, and I want to get the x so it's on the same side as the y. So we'll go ahead and eliminate it from here. All right, so write the x value first, then you have your y. All right, so these are equivalent equations. So I'm just going to rewrite my two equations I have now. So we have a negative 6x plus 3y equals 15, and then 6x plus y equals 9. Well, what's nice on this one is I don't have to do this thing. I don't have to do this because these are already going to add to 0. So that's kind of nice, and that's not always the case. So I might have to do that. That's usually the next step in this. It just didn't have to on this one. So these become 0. So we're left with 4y, 3y plus 1y equals 24. If you can hear the rain out there, having a rainstorm. So y is equal to 6. All right, well, I can go back into my two original equations and put a y 6 in for y. And I can do it on either one of these equations. It doesn't matter. I'm going to choose the second one, but I could choose the first one. Okay, so let's put a y in right here. So negative 6x plus 3 times 6. So negative 6x plus 18. And let's go ahead and subtract 18 so we can solve this for x. I hope that's not too loud and annoying for you guys. All right, now divide by negative 6. And x is equal to negative divided by negative becomes a positive. And 3 6 reduces down to 1/2. All right, so my solution is 1/2 6. Now, had I went back and solved this using substitution, would have got the same answer. So there's 3 different ways to solve it, and they all give you the same answer. It just kind of depends on how the problem is given to you, right? So normally, I would say if the problem is given to me like this, I'm going to use substitution because I don't have to do this step then. I can just substitute it in here. But if I'm given a problem like this where your x and y are on the same side, I'm going to go ahead and try and use elimination for that. All right, so how about this one? All right, so how about this one? This isn't on your study guide. All right, so right, do you see that these are both on the same side? X and Y are on the same side. They have coefficients bigger than 1, so really the easiest thing to use is elimination. So I either want to make the y's the same but opposite signs, or the x's the same but opposite signs. So it doesn't matter. I'm just going to choose the y because they're smaller numbers, but it doesn't matter. So what I want is I could make these both a 6. This one's already a 6. So if that's the case, I only have to deal with this one equation. I don't have to do like I did up here at the top with these two, because they both had to change to get 12. That's not the case down here. I only have to change one of them. So let's do that. So here, I need this to be a negative 6. So when I add it to that, it's 0. So I'm going to go ahead and multiply this by negative 2, which means I have to multiply everything in that equation by negative 2. So distribute that negative 2 through. This times 3y, negative 2 times 0. Lots of students make that a negative 2. They'd forget you're multiplying. All right, so then down below, I write down whatever I had here. Well, this is kind of interesting. So here, when I add down, would you agree that both of these are 0? So I end up with 0 equals 0. Well, what that means is that these are infinite solutions. So if I were to graph, do you recognize they're the same line? So if I graph them, it's going to be one line on top of the other line. So they just have everything in common infinitely, positive, negative numbers infinitely both directions. It's all real numbers. Whereas before, when I did this and it came out here, they didn't come out to be the same number. That's a no solution. That means they do not cross. But if they turns out like this, where it ends up being 0 equals 0, that means that those lines, it's one line on top of the other line. So they have every single point in common. So it's infinite solutions that they have in common. Okay. All right. Now on your study guide, we are not covering the inequalities. And I'm kind of disappointed because I wanted to do that, but we don't have time. So we're not going to do that. So I'm also running out of paper, so I'm just going to flip this over. I'm going to do these last two problems that are on your study guide just to do a couple more, so you have a couple more examples. So this one says, all right, just solve however you want. So I'm just going to put up here, you choose, meaning you decide how you want to solve these. So this is what you're given. So you can choose graphing, substitution, or elimination. All right, I would look at that and go, okay, well, I already have a y solve for. I'm going to go ahead and use substitution. And I'm going to put this in for y right there. All right, now if you chose something different, it's okay. All three will give you the same answers. You have to be kind of cautious with the graphing though. All right, so let's do that. So let's put this in for y. So we have 4x. In place of y, we'll put a negative 2x plus 3, and then equals 1. Okay, distribute the negative 3 through, so that becomes a positive 6x minus 9 equals 1. Combine your like terms, 4x plus 6x. Oop, forget the x. All right, now let's eliminate this. And then we'll just divide by 10. Divide by coefficient, so x is equal to 1. All right, now I got to find the y. So let's take this and put it back into here, or here, either one. I'm going to choose this one, I think it's easier. So y is equal to a negative 2. In place of the x, we'll put a positive 1. And then we'll solve that for y. So y equals a negative 2 plus 3, so y equals 1. So where those two lines cross, my solution is 1, 1. All right, one more. How about this? So here we have all right, so let's take a look at that one. So you have some different options. You have 3 different ways to solve it. I could use substitution, and if I did, I would choose to solve for this. So I could just subtract 4y over 4y here, eliminate it, because then I just have an x equals, right? And I'm back up to kind of what I was here with the y equals. Or, which is what I'm going to do, I'm just going to use elimination. And I'm going to try and make either the x's or the y's the same opposite numbers, so they add to 0. Well, I could multiply this through by negative 6, right? And that would make that. Or I could multiply this through just by a positive 2 because the signs are already opposite. So I could do either one, it doesn't matter. I'm going to go ahead and just choose the top one just to keep my numbers a little bit smaller. So I'm going to multiply this through by 2. Or, like I said, I could have multiplied this through by negative 6. Either way, you have some choice in that, which makes it kind of nice. So let's distribute here. So 2 times 6x, 2 times a negative 2y is a negative 4y, and then 2 times 6 is 12. So don't forget to multiply this through. Students forget that. That's the biggest error I see is they forget to multiply this number times this on the other side of the equal sign. All right. And so if you show your work like this, it's easier to remember and you don't make those errors. All right. So here then we'll just write down what we have. We don't change that equation at all. All right, so now when we add these, that's going to be 0. So we've eliminated the y. So 12x plus 1x is 13x. 12 plus 14, 26. So we'll divide by 13, and x is equal to 2. All right, now let's go back in here and choose either one of these, or these are equivalent. I could do that too, but I'm just going to go with this one. I could choose this one. I'm going to put a 2 in for x. So here, I'm going to put a 2 in for x. And then we'll just solve that for y. So negative 2. And then we'll divide. So y is equal to 3. So our ordered pair, don't forget to write it as an ordered pair because that's what you're finding is the ordered pair, not these individually. You need to write what the solution is. All right, so the last thing I just wanted to show you, if you have your study guides out right here, just so you understand what it's asking, if you want to fill in the blanks. Okay, so if we use the elimination method, which we did, and it ends up being something like 0 equals -1, where on our graphing one, it came out to be 12 equals 8. Okay, so they're just saying that these are not equal. That's what it means. It doesn't have to be those specific numbers. Then that means that system's going to be no solution. Those lines aren't going to cross. So they're going to be parallel lines, right? They're going to be lines that don't cross. Now, if I use the elimination method, and it comes out to be 0 equals 0, then that means I'm going to have infinite solutions, because what it is it's the same line you're graphing, so it's the same line on top of it, so it's just the same line, which is infinite solutions. If I have intersecting lines, that's all those others that just cross in one place that have one solution. That's when you're going to have intersecting lines. They will intersect in one place, and because they're linear, they will only intersect in one place. Okay. All right, just so if you wanted to fill those out, we'd have that. All right, so that's all I have for you tonight, guys. We should have an assignment posted for you, so let me know if you have some questions, and hope this helps you out a little bit. All right, have a good one.